Lesson 42 Use Memo. 1. Introduction. Good morning, afternoon everyone. Today we will explore an important concept in modern user interface development, the mechanism provided by frameworks like React to cache computational results between renderings in order to optimize performance. The focus will be on how and when to apply this tool, its benefits, and common pitfalls. 2. What is useMemo and why does it matter? The feature under discussion, used in React, allows a developer to wrap a calculation so that its result is stored and reused across multiple re-renders of a component, so long as certain dependencies remain unchanged. In essence, it's a means of memoization, storing a value so you don't have to redo the computation each time when nothing relevant has changed. The reason this matters is that in a UI framework each component may be asked to render often, and if the render logic includes heavy calculations or transformations, you may introduce unnecessary overhead. useMemo is intended as a way to skip those redundant operations. 3. Parameters and basic behavior. When you invoke this mechanism, you provide two things. First, the calculation or function whose result you want to cache. This calculation must be pure, meaning that it does not depend on side effects or mutate shared state, so that its output is stable given the same inputs. Second, a list of dependencies, the values, props or state pieces that the calculation uses. On each render the framework will compare the current dependencies with their previous values using a strict equality comparison. If none of them have changed, the previous cached result is returned and the calculation function is not executed again. If any dependency changed, the calculation runs anew, the result is returned and cached for subsequent use. On the initial render the calculation always executes and returns a value. On subsequent renders it may be skipped if the dependencies are stable. 4. Primary use cases. There are several scenarios in which memoization is appropriate. Skipping expensive recalculations, when a component must perform a heavy computation, filtering a large list, sorting, complex transformations, and the inputs to that calculation rarely change, memoizing it avoids repeating that work on every render. Avoiding excess re-rendering of child components. If your component passes a computed value as a prop to a child component which is wrapped in a mechanism to skip rendering when its props are unchanged, then caching the computed value ensures that it remains referentially stable, that is, the same object reference, between renders. This stability allows the child to skip re-rendering simply because the prop reference did not change. Preventing an effect from firing too often. Some side effects, network connections, WebSocket initializations, subscriptions, depend on values or objects. If those objects are recreated on each render, the effect may fire repeatedly. Memoizing the object used as a dependency prevents unnecessary re-invocations of the effect. 5. Important caveats and best practices. It's crucial to recognize that this tool is not a cure-all. A few important points. It should be treated as a performance optimization only. If your code fails or behaves incorrectly without using it, you have a deeper logic issue. You must fix that first before relying on memoization. The calculation itself must be pure and free of side effects. Impurities or mutation of external state will undermine the effectiveness and may even introduce bugs. In development mode, frameworks may call the calculation function more than once, for example, in strict mode, as a check for impurity. This doesn't affect production behavior but is important for testability and predictability. If the dependencies change frequently, or if you forgot to specify them fully or correctly, then the caching will fail, the calculation will run each render, and you gain nothing. Overusing memoization indiscriminately can reduce readability and increase complexity with little benefit. If the computation is trivial, or inputs change often anyway, memoization is likely unnecessary. Dependency references matter. If you pass an object or function that is created fresh on each render, then the dependency array will detect the new object reference and consider it changed, invalidating the cache. In such cases, you may need to memoirs that object or function too, or restructure your code to avoid recreating it. 6. When you don't need it. Quite often, you don't need to apply memoiration at all. If your component's render logic is lightweight, the dataset is small, or you're not passing computed results to memoirs children, the cost of adding the complexity may outweigh the benefit. For many apps, minimal optimization is perfectly sufficient. Only when you observe performance lags, slow rendering, heavy interaction stalls, should you consider measuring and applying this tool. Profiling helps determine precisely whether the optimization is worthwhile. 7. Troubleshooting common issues. Let's review a few common problems and how to address them. My calculation seems to run every render even though dependencies looked unchanged. Check whether you correctly passed the dependency list. If that list is missing or incomplete, the system cannot know the dependencies are stable and will recompute each time. The value returned from memoiration appears undefined or incorrect. Often this stems from using a function body that does not explicitly return a value. Ensuring the calculation returns the intended result fixes this. The dependency is an object or function created inline and thus changed on every render. To avoid this, either memoirs that object or function itself, or refactor so that you pass in primitives or stable references as dependencies. You attempted to call the hook inside a loop or conditional block. Because hooks must always be called in the same order on every render, placing them inside loops or conditions violates rules of hooks and leads to unpredictable behavior. The solution is to extract logic into separate components or restructure so that the hook is always invoked in top-level component body. 8. Summary. Memoiration of calculations in React via this hook enables caching of results between renders when dependencies remain unchanged. It is most beneficial when dealing with expensive computations, stable inputs, or when used in conjunction with prop-based child component rendering optimization. It is not intended to solve functional correctness, and misuse, either by overuse or by incorrect dependencies, can introduce complexity or subtle bugs. Always prioritize clean logic and readability, then apply memoiration when profiling demonstrates a performance benefit.